Hello, so today we're going to continue our discussion of polar equations, and we're going to try and make some sense of what we did yesterday when we were investigating them. Yesterday we looked at really three different kinds of polar equations, but two of them are here. The first is this right here, the a plus b sine theta, or the a plus b cosine theta. And what we found yesterday is that those are what are called limacons, and they can be the things with the loops, right? You can have that loop, the limacon with the loop, or you can have one, if we are going, say, this direction, you can have ones that have no loop and are called cardioids. You can also have ones that kind of come out here. And we came up with some ideas about why they do different things, or when they do different things. And today we're going to look at sort of why that happens. And then we're also going to look at a sine b theta and a cosine b theta for r. And though we got what were called the roses, which draw in lots of different ways, and we can get shapes like that. And so we're going to investigate that a little bit. All right, we're going to start with going back to rectangular and what we know about cosine and sine graphs. So here we have y equals 1 plus 2 cosine theta. Without using our calculator, with just using our awesome brains, we should be able to sketch a graph and think about what this looks like. And for now, I'm going to talk about the most important thing is what is our maximum value. And you can get your maximum of a sinusoid by taking your sinusoidal axis, which is 1, which is your center, and then adding your amplitude up. So from 1, we can go up to a high of 3. And from 1, we can go down to a minimum value of -1. Okay, so I know that if I'm over here, my sinusoidal axis would be at 1, and I would go up to and down to. And my sinusoid is going to be contained between those y values. All right, other things to think about to make sense of these polar graphs is it always helps to think about it, because we're going to be looking at graphing them starting when theta is 0. So I want to know when theta is 0, where am I? What is my y value? Well, if theta is 0, I have 1 plus 2, cosine of 0. And you should know from your trig exact values that cosine of 0 is 1. So we have 1 plus 2 times 1, which is 1 plus 2, or 3. So at theta is 0, our y value is 3, and we are right up here at the very top of this graph. Then I want to know, where does y equal 0? So when am I crossing the x-axis? And I can do that by setting 1 plus 2 cosine of theta equal to 0, and then I solve for theta. We want to undo all those outside transformations. I would subtract 1 and get 2 cosine theta is -1. Divide by 2. Cosine theta is -1/2. And then in my head, or I can sketch it out, I'm trying to figure out what values for theta. And right now we're just going to go 0 to 360, although later we might have to go higher. But where would cosine be negative? Cosine is my x-coordinate, and I'm negative in quadrants 2 and 3. And I know that my cosine is my short side, and this happens at the 60-degree angle, so at 120. And if you like the radians, that would be 2 pi over 3, and also 240 degrees, which would be 4 pi over 3. And so, and then my last question here is, on what intervals is y equal or less than 0? So, and I'm going to get that after I do my graph. So right now I think I have enough to sketch a graph. I know that my normal period, my period is 360 because I haven't done any shrinking or stretching horizontally. And so I'm going to come down to -1, and I'm going to go back up, and that would happen at 360 degrees. And then I just figured out from my from this part right here, where does y equal 0, that this value happens at 120 degrees, and this value happens at 240 degrees, which should make sense that there's some symmetry. That's my 180. So then that tells me if I look at this graph, where is y less than 0? That's going to be right down here. So from 120 is less than theta is less than 240 degrees. I graphed this earlier. If we just get rid of that, there is the matching graph. That's cosine. It's stretched it a little more, but you get the idea. Now I'm going to use this idea of the max value, the min value, and where y is less than 0 to help me make sense of this limacon graph. And now instead of y, we have r. And so instead of a vertical height, we have r is the distance from what's called the pole here, but we are also going to call it in the Cartesian is the origin. Okay, so that's what I'm trying to figure out. And I can think of some of those same things from that I used before. For example, I know that the maximum radius is 3, and my minimum radius is -1, which means that I will never get farther away from the center of that graph than 3, and I will never get farther, or I never go backwards farther than 1. And so when I'm setting my scale, you can set, if I did every one, that might be a little bit small, so it can help me that way. Other things I want to think about is when theta is 0. I want to start drawing this graph. I need somewhere to go. If I only have to go out to 3 or -1, I could make it every 2 units instead of every 1 unit and still have some space. So I'm going to do that. When theta is 0, right, we said when theta is 0, my y was 3. And that's going to be my radius. So when theta is 0, so this is my starting point right here. And that relates to this point right there. And then what happens to my radius is it gets smaller because the y value on the original graph, on this graph, which is y equals 1 plus 2 cosine theta, is now the radius value. So my radiuses are going to shrink until I get a radius of 0. In other words, I'm back at the origin, or in this case, at the pole in polar at 120 degrees. And so we're going to graph this on our calculator and sort of take a look at what's happening. So I want you to pull out your calculator, pause the video if you don't have one, and then we're going to set a few things. So to do this on our calculator, we are going to work in degree mode for now. Later on, if you get really good, you can think in radians. We're going to set it in polar mode so that we have our r equals equations. And then the other thing I'd like you to change is I want you to go, instead of sequential right here, I want you to go to simultaneous. And that's going to allow us to graph things at different times. Actually, that's not going to be important for this, but it doesn't matter. It's kind of fun. So then I'm going to come up here, and I'm going to delete this. And I'm going to type in my function, 1 plus 2 cosine theta. I want to look at my window. I am in degree mode. So the first two things are my theta min and theta max. I don't want to go to 2 pi because I'm not in radians. I want to go to 360 degrees. Hopefully that'll give me a whole cycle. And theta step, if I went 0.1, that would be a very, very slowly drawing graph. Now I said that my maximum radius is going to be 3, so I don't need to go all the way out to -10 for x or for y. I can go from -3 to 3. And hopefully that will help me see the graph a little bit better. So I've set my window. You can pause and set your own window. And now I'm going to hit graph. Oh, I'm going to do one more thing first. This is one of my favorite tricks with, especially with polar, when you're trying to get a sense of how this is growing. If you cursor over to the left of your equation and you hit enter, that would graph a very dark line. And then this is the one I like the most, the bouncing ball. Number 1, it graphs a little slower, and you can sort of see the movement as we go around. So we're going to hit graph, and we're going to watch what happens. So there I am, starting with a radius of 3. My radius is shrinking until I get into 0, and then I'm drawing this loop. And then I come out of my loop. And then I keep going, and then I end up at 3. And I'm going to take that, and I'm going to put it over here, and we're going to do a little analyzing of this. So here's this graph. We can draw it up here, but I think more important is let's just analyze what we did right here. Okay. So what happens on my graph is this green part right here is from 0 degrees all the way to 120 degrees. My radius started at 3 way out here, and it got smaller and smaller and smaller. So as I went around the circle, my radius got smaller. So I went this way, zoom, and I came in. And at 120 degrees, which if I pull a little line out, let's do a line like this. At 120 degrees, which is somewhere up here, oops, right, that's when my radius started to get negative. So this negative radius right here, and I went backwards a maximum of 1, right? I went down 1 from there, is this right here. So from 120, right, now I'm at 120. So when I'm really graphing out here, I am going backwards. So instead of going out that angle, I'm going backwards all the way to, this is at 120, and this right here is at 240. And if I imagine another sort of dotted line at 240, which is a little farther down here, right? If you notice, in that sector, in this part right here, I don't have positive angles. I don't have positive radius. I have that negative radius, and there's my loop. And then I finish, so I have a radius of 0 right here. My radius gets bigger until I go back up to 3, and that's what's happening from 240, 270, and I'm going to 300, 330, all the way back to 360. It gives me that piece of the graph. So that's why we get the loop right here. And we talked about this yesterday when A is less than B. We have a limacon with a loop, and it has to do with this rectangular graph. It has to do with having a positive maximum and a negative minimum, because that negative minimum means I have negative values for r and I go backwards, and there's a piece of my graph that has a gap, and I have that loop. Okay. Now let's look at another graph. So now we're going to look at one of our roses and see sort of why this graph's the way it does. So again, I want to know my max and my min. My max in this case is 6. My min is -6. So that means it's as high as I'm going to go and as low as I'm going to go. And I haven't done any shifting up or down because their sinusoidal axis is 0. Again, I want to know where am I starting. So when theta is 0, what is y? Well, y is 6 sine of 3 times 0, or 6 sine of 0, and sine of 0 is 0. So at 0 degrees, I am starting on the sinusoidal axis, which is on the x-axis in this case, because I haven't done any shifting up or down. Where does y equal 0 is my next thing. So I say 6 sine 3 theta is 0. And again, undo your outside transformations. I'm going to divide by 6, and I get sine of 3 theta is 0. And now I have to undo the sine. And so I think in my head, what values for theta have a sine of 0? And if I think about my circle, my sine, which is my vertical, is 0 here and here. And if I start labeling out those angles, it's at 0 degrees, 180 degrees, 360, and I think I have to keep going because of this 3. Next would come 540, and then 720, and I should keep going. And 360 is going to be, well, 300 would be 1020, so 1080. Oops, I can go 180 first. 180 would be 900, and then 1080. Sometimes this is one that it might have been easier to do in radians. All those angles, and I could keep going forever, are angles where theta would be 0. But these are all what 3 theta is, okay? Because that's my argument. That's this thing right in here. So that means that then theta would be 1/3 of all of these. So at 0, at 60, at 120, if you divide 540 by 3, you get, we can just do, you can see we're going up by 60 every time. So if I come out here, and I can find some of my answers if I take 0, oops, let's delete that. Enter, and I'm going to add 60. That'll give me some multiples, 120, oh, and then 180, 240, and so forth. Okay, on one intervals is y less than 0. Well, that's where my graph is going to help me. So I'm going to go here, and I know that by the time I do 360, I'm going to have done 3 whole cycles. And so I go up to 6, down to -6, back to 0. And that right there took me 60 degrees. And then another cycle is going to be another 60. I'm sorry, I did not mean that my period was 60. I meant that I hit 0 every 60. So this is 60, this is 120, and that should be my period. 360 over 3 is going to be 120. So 120, and then I have another 120 is right here. Yeah, 60, 120, 180, etc. So all those places. So then when is y less than 0? Well, the first interval where y is less than 0 is from 60 to 120. And then I go positive for a while, and then I could have another interval, which would be 180 to 240. And so that's sort of what's happening. Okay, and I get that picture. Now we come over here and we're going to relate that to our r equals. So now our radius again, the highest our radius will go is 6. Since I don't have such a big thing here, 1, 2, 3, 4, 5, 6, every 1 unit is going to be 1. Now at 0 degrees, I said, if we think back here, at 0 degrees, what was my y, which is now going to be my radius, and my radius was 0. So again, I'm starting at the pole. And then as theta grows, right, if I think about this graph, my radius is increasing first. It's going to increase until I get up to here, and then it starts to decrease back to 0, and I'm back at 0 by the time I hit 60 degrees. And we should see that on our calculator. If we come back up here and we type this one in, we have 6 sine 3 theta, and I'm going to hit graph. So there is 0 degrees. Whoa, let's stop that. I want to change my window because I need a bigger window this time. -3 to 3 will not actually let me see what's happening. I want to go -6 to 6. That's the max radius. So that should work for a window. Now we'll hit graph. So there we go. Up to there. There's 60 is where we're back at 0. And then I'm at 120. And then notice this traces itself. As I go to 360, I go back over the same angles once again. Okay, I'm going to pull that over here. I'm actually going to pull that in here. Okay. So as we did our thing, we had positive radius to 60. That was 60 degrees right there, which should make sense. That's like 60 degrees right up there. And then I started going negative. And so in this section from 60 all the way to 120, if I look back here, from 60 to 120, I had the negative radius, and I get my radius is coming backwards. As I traverse from here to here, I graph not up here, but in the reverse direction. So that's back up to 120. I get back here, and then I graph forward again from 120 all the way to 180 as you're going around the circle, right? From 120 to 180, I am positive, right? That's positive. And then from 180 to 240, I go negative again. So in here, the 180 to 240, that's when we are retracing this part right there. So that hopefully gives you a little insight into why the polar graphs do what they do. If we look at the cosine graph, very similar to the sine graph, my max and min are the same. What is different is when theta is 0, what's my y? And so in this case, I'd have 6 cosine of 3 times 0, or 6 cosine of 0. And cosine of 0 is not 0 like sine of 0 is. Cosine of 0 is 1, so I get 6. So now instead of being down here like sine, I'm up at 6. And how that relates to my polar graph is instead of starting here and going out, I'm going to start out at 6. Last piece, where is y 0? If 0 equals 6 cosine of 3 theta, again, I'm going to divide by 6. cosine of 3 theta is 0. And now instead of where is sine equal to 0, where's cosine is 0, and cosine is about my x, and that's at my 90, 270, and then 450. And again, I can keep going. When I divide them by 3, right, so this right here is 90, and this right here is 27. Oh, wait, I haven't divided by 3 yet. I have to divide by 3. So this is 30, and this is 90, and this is, I believe, 150. Again, I'm adding 60 every time, and then my next one would be 210. So on this graph, this is going to happen at 30. This is going to happen at 90. I'll go up and I'll come back down. Again, this is a really bad cosine graph, but 150 and so forth. And so that relates when I go and graph this, the difference between the sine and the cosine graph. If I just come up here and I hit cosine and I go to graph, again, see, I'm starting out at 6. And my first interval only goes to 30 before I hit 0. Right. And then again, this, like the sine graph, traces over twice before I am done. So if I pull that out and we pull it over here, right, here we go. I started out here at 6. This was 30 degrees. And then, so all the way from 30 to 90, I'm tracing this backwards piece right here. Right? And then from 90 to, what did I say, 150? Right? Was it 90 to 150? Yeah, 90 to 150, not that, this. Right, this is at 150. I have positive values, and then I start going from 150 down to 210. Again, so from here to here, I'm going backwards on this negative loop. And hopefully then you can understand a little bit more about your polars.